Welcome to this explainer. Today, we are unlocking an absolute mathematical cheat code, the laws of exponents. Now, these aren't just abstract rules on a chalkboard, they're actually the underlying engine of how things scale, multiply, and grow in our everyday lives. Let's get right into it.
Okay, let's dive into this with a tangible puzzle. Picture a single bacterium in a petri dish that doubles every hour. Hour 1, you have 2. If we start with just 1, how many are there after exactly 10 hours? Take a quick mental guess.
Boom! The answer is a massive 1,024 bacteria. Talk about escalating quickly, right? If we tried to actually map this out by writing down the repeated multiplication, 2 times 2 times 2, it gets super tedious and messy. We clearly need a shorthand.
So here is our roadmap for today. 1. The power of doubling. 2. Anatomy of an exponent. 3. The 5 essential laws. And 4. Solving real-life problems. Section 1. The power of doubling. Let's look closely at exponential growth. Just listen to this growth pattern. We start with 1, then 2, 4, 8, 16, 32. You can literally hear the acceleration. Imagine having to write out 100 2s just to calculate the 100th hour. Yeah, that's a recipe for error. And that is exactly why mathematicians created a shortcut.
Moving on to Section 2, Anatomy of an Exponent. Let's define the base and the power.
Okay, so an exponential expression basically has two main parts. You've got the base, which is the actual number being multiplied. Then you have the exponent, that little number up top, which tells you exactly how many times the base is used as a factor. So, in 2 to the power of 4, 2 is the base and 4 is our exponent.
And this brilliantly illustrates why exponents are so incredibly efficient. Doing it the long way, multiplying 2 by itself 4 times, is repetitive. The short way, 2 to the 4th power, is clean, it's elegant, and it communicates the exact same truth in just a fraction of the space.
Section 3. The 5 essential laws. Let's open up our math toolkit.
We are going to cover 5 essential laws today: the product rule, quotient rule, power of a product, and the zero exponent rule. Let's just walk right through them, one by one. First up is the product rule. When you're multiplying powers that have the exact same base, you just add the exponents. It's that simple. So for 2 to the 3rd power multiplied by 2 to the 2nd power, we just keep that base of 2, add the 3 and the 2, and that gives us 2 to the 5th power, which equals 32. It literally turns complex multiplication into simple addition. Let's move to and see how this builds into the quotient rule. Think about it. If multiplying meant adding those exponents, dividing means doing the exact opposite, subtracting them. So 5 to the 4th power divided by 5 to the 2nd power, we keep our base of 5, subtract 2 from 4, and that leaves us with 5 squared, which is 25.
Rule number 3 is power of a power. When you raise an exponent to another exponent, all you got to do is multiply them. If we have 3 squared and that whole thing is raised to the 3rd power, just keep the base of 3 and multiply the 2 and the 3. That beautifully simplifies to 3 to the 6th power.
All right, our 4th rule is the power of a product. When you have multiple factors inside parentheses being raised to an exponent, you just distribute that power to each factor. So 2 times 3, in parentheses, all squared, becomes 2 squared times 3 squared. That's 4 times 9, giving us a grand total of 36. And finally, the zero exponent rule. Now this one sometimes trips people up because it feels a little counterintuitive at first glance. The rule states that any non-zero number raised to the 0 power is simply 1. So the crucial point is this absolute mathematical consistency. Whether your base is 7, 12, or literally a million, if it is raised to the 0 power, the answer is always exactly 1.
Section 4. Solving real-life problems. Let's see how this math plays out in the real world. Let's jump back to that initial puzzle, a single bacterium doubling every hour for 10 hours. Now that we actually understand bases and exponents, we know the base is 2 because it's doubling, and the exponent is 10 because it's happening over 10 hours. By simply writing 2 to the 10th power, we solve that massive growth puzzle instantly. 2 to the 10th is exactly 1,024 bacteria.
Now, what's really interesting about this concept is just how universally applicable it is.
This kind of repeated multiplication doesn't just happen in tiny petri dishes. We see it in finance, where compound interest makes your savings double over time. We see it online, every time a digital post goes viral and gets shared over and over. We even see it in demographic models. Seriously, exponents are everywhere.
Which brings us to the end of this explainer. But before we wrap up, I want to leave you with a quick, thought-provoking question. Where do you see things multiplying, doubling, or grouping repeatedly in your own community? Now that you're equipped with this mathematical toolkit, I bet you'll start spotting exponential growth everywhere you look. Thanks so much for joining me. Keep an eye out for those patterns, and I'll catch you in the next one.